All right, so we started out real simple. We started out with a couple of roots. You set them equal to 0. You get your factors. You get your equation. Yes, you can leave this in factored form as well. I know, this always happens to me. You can leave it also in factored form. Okay, if you left it in factored form, I'm okay with that. This one wasn't so bad, so you left it like this, that's okay. This is kind of a nice way when you leave them in factored form, we can right away spot your roots right there. You can tell what your highest exponent is still by just multiplying your x values, and you can see it a little bit better. But make sure you give me some kind of equation. It's got to be equal to something. It just can't be an expression. So if you're coming up with the equation, make sure it's equal to f of x, equal to y. Make sure it's equal to something.
Equal to 0?
No, it has to be an equation equal to y, equal to f of x, some, g of x, whatever you'd like to call it. But it's got to be some kind of equation. Okay. Again, this one you had just basic, just getting your pattern. If you leave it to me like this is absolutely fine. I didn't give you anything too pressing on that one. That has 4 roots. The x I put back here. You could put it in the front, probably make life easier. It doesn't matter what order your factors come in. Any questions so far? No? Okay. All right. Then we had to sketch and describe a little bit. So your highest exponent is a 3. It's positive coefficient. So your ends are going down on the left, up on the right. So that's a good place to start. Second place, find your roots. So you're going to find your roots. This is a double. Double meaning it's bouncing off. Here it is bouncing off here. A single one will go through, a double one will bounce off. So that gives us 3 roots altogether. So when you do this, you should be able to go from here, the 0, and at the -6, you know that it has to come down on the left. This is the leftmost one. It's got to come up on the right. This is the rightmost one. So somewhere this has to go smoothly. Somewhere I have to connect this like this, somewhere, to come around and go like this and bounce off here. This is the one we don't know. How high is this thing? Should I make it a small one? Should I make it a large one? In a sketch, as long as you just have like the flow of it, you're fine. If we do it on your calc because we need to find the min or the max, it kind of puts it in a little bit of a better perspective. And as long as you can use your calc, you can absolutely graph that. But we can do it without your calc. We just don't know how low or how high those go. Inflection points, can everybody find their inflection points? It means I was concaving down here, then I was just going to concave up here, and the part that I overlapped, I have to share. So halfway through is my midpoint. Find your midpoint of your axis, and then do a calc val, find your y. In this case, yeah, it does work the midpoint of your y's. So you're concaving, and again, your increasing, decreasing go by your x's, so does your concavities. Remember to call them relative mins, relative mens. You got a lot. See how things are growing? It does make a little bit more sense in pre-calc than it does in Algebra 2. In Algebra 2, we kind of do something, we have to quick move on to the next thing. But in pre-calc, everything kind of grows. It kind of grows for a while. If you did your t squared times your t squared, that's your t to the 4th. So t to the 4th tells me I have either up or down. I have a negative coefficient because of the -1/2. So both my ends are going down. Set them all equal to 0. There's your zeros. I have 2 double roots, and I can see them both bounce off. I can see it bounce off here and bounce off here. Okay. How far down this dips, I'm really not sure. But if I put it in my calc, I realize it dips pretty far. Pretty far. Now, remember, you have 4 And your exponent, 4 roots, -1, 3 turning points, -1, 2 inflection points. So, and again here's your concave down. You have 2 caves that cave down. You have 1 cave that goes up in the middle. So it shares this part and this part. Just take the average of your x's and then concave to that point. Everybody's good with the concavities? It's a little bit of a different concept. It works different than your increasing, decreasing, because your increasing, decreasing works off your max and min. But the concept of giving an x interval as y is changing is the same. You have absolute, these are your absolute maxes and your relative mins. Is this an odd function or an even function? It's even. There's symmetry where? Over your y-axis. Good. Okay, your highest exponent is a 3, your coefficient is even. Down on the left, up on the right, you're going to factor. Set them equal to 0. Your inflection point is smack in the middle.
Right on the origin.
Right through the origin, because where's your symmetry? Through your origin. Is this an odd or an even function? Odd. So where's your symmetry? Right here. Through your origin. Aren't these the same? Same points? Opposite signs? There's your symmetry through your origin. There's your odd. If I put a negative x in here, this becomes negative x cubed plus 4x. If I factor out my -1, isn't it the exact same? There's my odd. Who had a question?
How do you tell if an exponent is less than 0? Because like, for the last problem, they both go up. Then wouldn't that mean that it's even?
It's even.
It's less than 0.
Wouldn't be less than 0. The coefficient is less than 0. The coefficient is positive or negative. Less than 0 would be negative. Greater than 0 would be positive.
The exponent was supposed to be less than 0.
No. The exponent has to be there. If it's a less than 0 one, then it's a negative. Then you have a fractional one. We didn't throw any fractional ones at you yet.
I don't like the fractions.
Be happy. No fractionals yet.
I just don't like them as exponents.
Now, here's a good example of leave them all in factored form. Isn't this much easier to work with than having to factor that all out? Just keep track of your x's. This gives you an x squared.
I'm over here keeping it in fractions.
Oh, okay.
And you put decimals, you're switching it up.
I switched to decimals where?
The inflection points and the concave up.
Oh, only because we do 3 decimal places. We do
I
rule
did
of-
fractions.
Oh, okay. And there's your x squared, so this gives you an x to the 4th. Guys, we get this? You need to put everything else away and be doing this. Because I really don't want to hear that I don't understand it. Okay. So find your their relative max over here. You have a relative min, you have an absolute min. Rule of thumb, 3 decimal places. So some of these are going to have to go 3 decimal places anyway. You might as well just leave them all 3 decimal places. Fraction, if you mix it in, that's fine.
Well, my calculator just gave it to me.
Give it to in fraction.
I don't know why, but it did. Yeah, strange, right?
Questions on this? Okay. So, synthetic division, and I'm surprised some of you didn't do it last year.
I don't remember any type of division last year.
Okay, now, we're going to start again here because I was just pulling these out. These don't really work. Alright, you're going to pull out all your coefficients. But your x's have to be accounted for. I think really you guys need to do this from the very beginning. They need to go down. x4, x cubed, squared, 1. This is x to the 0. You need to account for every position when you divide this. So if there's no position for them, we're going to put a placeholder of 0. So we're going to take this out, and we're going to take out all their coefficients. So I have a 1. X to the third, I don't have anything, so I have a 0. X squared, I have a negative 10. You don't have to put a positive, just put the negatives. X1, I have a negative 2. And X0, I have a 4.
Why is the thing like that?
Because you're going to see how we divide. We do this different.
I might have said already, I didn't catch it. Why is there an X third up there?
Because we're missing an X to the third. So they have to be exactly in descending order. So we have to put a space holder there. Otherwise, we're not going to count it when we divide.
Alright.
Now, before you do this, just check. The highest is a 4. 4, 3, 2, 1, 0. Okay? We're going to divide by this factor. If we kind of set this equal to 0, we see that our root is negative 3. So we're going to divide by negative 3. Okay. Good so far? All right. Now, you're going to follow a pattern when you go through this. And I had it on another sheet, but I didn't copy that sheet one down. So, first time through, you're going to bring down the first one. We need a starting place. You're going to multiply it from the left, and you're going to bring it to the right. So, negative 3 times 1, go to the right.
We did this.
Negative 3.
Aha.
See? I know you remember this.
I don't remember.
Okay, so follow this with me. Guys, you missed one step, you're done. So, negative 3. Add this down. Do it again. Negative 3 times negative 3 is what?
9.
To the right. Stop. Add it down. Negative 3 times negative 1 is what? 3. Add it down. 1. Negative 3 times 1 is negative 3. Add it down. 1. Now, eyeball this guy. I took this thing, x to the 4th minus 10, blah, blah, blah. I divided it by x plus 3. Look at the very front end, just like when you used to do front end division, just to guesstimate what your answer was. What does x4 over x1 come out to be? x3. Keep it real simple. So watch. This is x3, x squared, x1, x0. Oh, this guy's a remainder. So stay with me. Now, put those coefficients out. 1x cubed minus 3x squared minus 1, whoops, there goes my board, minus 1x plus 1. As soon as my board comes up, we will get the rest. Okay, minus 1x plus 1, and here's my remainder, plus 1 over x plus 3. The same way that you would put this over here, 2 over 3, you're going to do it with the same thing, the same way. You started out saying R2, then you went to 2 over 3. Now, if I took this answer and I multiplied it by this factor, and then I added 1, I would come back to the original 1. It's just a process. Bring the first one down, multiply left to the right each time. Stop, and bring it down. Okay? All right, let's try another one. Let's.
Oh.
All right. Let's look at the numerator first. Are we missing any coefficients?
No.
So we've got a 3, a 2, 1, and a 0. Okay? So we're going to take this out. 6, negative 16, 17, negative 6. 3, 2, 1, 0. Now, we need this leading coefficient here to be a 1. So we have to factor out a 3.
Oh.
We have to factor out a 3. We're going to come back to that factor. So this is really important that you factor out this 3, because every time you do this, it was a 1 on the last one, it has to be a 1. Just circle this. If I have to circle it, put a star because I forget to come back. So factor out a 3, we got to keep track of that factor. Remember when you complete the square, when you factor something out, what do you do with the factor at the end? You have to distribute it back out, right?
Yeah, but I have a question.
Oh, 2/3, sorry.
Yeah.
Yeah, sorry. I'm talking and writing at the same time. Yeah. Sorry. So we okay with that? Factor out this 3. All right. God bless you. I'm sorry. I didn't mean to scare you. Okay, set it equal to 0. Keep track of that 3. That 3 comes back to haunt you.
Oh,
Do you need to keep it 3 though?
And yes, we have a fraction, but it's okay. Just circle that 3 for a minute. We're going to leave that separate, and we're just going to take this.
These just equal to 0. which
And if I
is
put it equal to 0, yes, but the problem is you wouldn't go back and factor out the 3.
Alright.
You're going to see it at the very end. Yes, I realize you could set it equal to 0. Okay. All right, so now, same process. Bring down the 6. What's 2/3 times 6?
Sure, I'm not doing mine.
Come on, 6 times 2 is
4.
12, divided by 3, 4.
4.
Add it down,
-12.
okay? Do 2/3 times -12. -24 divided by 3, -8. Add it down. 9. Do 2/3 times 9, 6. So I'm just putting a plus 6 so that you see that this is going to cancel out. This is going to cancel out to 0. This means that I have no remainder. This means that this guy was an actual factor of this. Now, we have to use this 3 over here. Because we factored this 3 out of here, this 3 has to get factored out of here. We have to factor it out of here. Remember when you do your other one, you factor it out, then you distribute it out like that? Once you factor it out, you have to factor it out of here. That's why we factor it out and we keep track of it. Yes.
I mean, obviously the remainder is 0, but would you take it out of the remainder?
Yes, you would. Yeah, you would. But right now we're 0, so we're okay. So just before you do any x's, divide this out. Now, front end division. Say to yourself real basic. What is x3 over x1? X squared, x2, x2, x1, x0. So we have 2x squared minus 4x plus 3. So that's another factor of this. Yeah. Oh, I just, so that you'd see it.
Oh.
Yeah, for no other reason. Because that whole thing gives me a factor. So if I took this times this, I would get that. Okay, if I went and multiplied them out, I would get that. Now, and you know what you can do, you can let your calculator do this if you want. This is a very easy way to check. In your y1, just put this numerator. Just your numerator. In your y2, put the other parts that you're adding. You're checking. Just see if that's the same. Because all you want to do is multiply those back to equal the top one. So rather than do the whole thing by hand, just let your calculator show you that it's the same thing. It would be kind of meaningless to look at the calculator, but you'll see that it means the same thing. All right, so just remember that that first coefficient has to be a 1. Okay, now we just throw another little thing in at you. Now we have 3 terms, and our first coefficient has to be 1, which it is. Okay, so we're only going to take your last 2 terms. This one's the toughest one, guys, because we're going to do this double. Now, we're going to take this out the exact opposite way. You're going to take the bottom out. Let's take your top out first.
1,
1.
-2, 5.
Okay, so let's bring this down. 3, 2, 1. Whoops, I'm missing an x to the 0. I have to go all the way down to x to the 0. I don't have an x to the 0. So 3, 2, 1, 0. Now, my leading coefficient is 1. That has to happen. or I would have to factor it out, and I would have to worry about it at the very end. Always factor it out, circle it, star it. I have to put stars around mine because I usually forget to go back, and when I check, I say, what? So now, take this out the opposite way. 3, comma, -1.
Are we gonna have to do it twice?
Yes. Take it out the opposite way. This is like as if you set both of them equal to 0. All right, so now we're going to start like this. Bring down the 1. Just watch the first time, and then I'll do it again so that you can do it with me. Because if you miss the pattern by looking up and down to write it, it's very difficult. We still multiply from the left. We put it to the right. But we have 2 parts to do. So 3 times 1 to the right is 3. -1 times 1 to the right is -1. I stop. Yep, we have 2 things to do. 3 times 1 to the right. -1 times 1, but I already took that spot. I got to go to the right of that. Okay, just watch. Don't write.
I'm watching.
-2 plus 3, 1. I'm going to do the same pattern again. 3 times 1 to the right.
3.
-1 times 1. Now, I'm at the very end. When I'm at the very end, I stop and add everything down. So this gives me, excuse me, this gives me 8 minus 1, 7. This gives me a -1. Now, front end. x3 over x2 gives me what? X to the 1. x1, oops, sorry, x1, x0. This is my remainder. So work the remainder backwards. x0, x1. So my answer, I just worked it backwards because you're only going to have 2 terms in your remainder. So the last 2 terms, because they're 2 terms, they have to go in order. So just work that one backwards. So this gives me 1x plus 1 plus 7x minus 1 over this remainder. Is that a plus or a minus?
Minus 3. Okay, I get it.
Okay,
No, wait.
this is my answer. I like to put these in parentheses so it doesn't get confused with your remainder. Sometimes kids write the remainder and it looks like it goes across everything. We're going to do it again.
You say you go backwards, shouldn't that be like
This
minus
is
x
backwards.
squared?
x0, x1. You're only going to get 2 terms in your remainder. So the last 2 terms, this is a 0.
Oh, okay.
I thought it was a 2.
I'm sorry, that's a 0.
Confusing me, this is 1.
Sorry. All right, so let's do this together.
Wait, can I just ask?
Yes, you absolutely can.
So, like, say there were 3 like things in the remainder, like that other one, so then it'd be x0, x1,
There
x2.
won't. Well, there'll only be 2.
Well, but like,
Yeah.
if there was.
Yeah, then it would be x0, x1, x2.
Okay.
Just go backwards, but there'll be 2. We don't make this life too difficult for you. We usually, if we're going to put 3 terms, we usually don't go too far on the side. All right, so let's pull out your coefficients. Pull out your coefficients from your numerator. What would they be? 1. I'm just taking my I'm doing this again so that you could do this with me. -2, 5. Now, 3, 2, 1. I need a 0 term. Even though it's missing at the end, I still need it. Now, our leading coefficient is 1, so that's okay. So I take this guy out the opposite. I take this guy out the opposite as if I set them both equal to 0. We didn't do that on the one before because we only had 2 terms. We always work with the last 2 terms. So now, let's bring the 1 down. You're still multiplying left to right. You just have to keep going to the right. So 3 times 1 is what? 3. We got to do this guy now. -1 times 1 is -1, but I already used this spot, so I go to the right. I stop, and I just add this guy down.
That's 1.
This gives me 1. Now I start my process again. 3 times 1,
3.
3. Negative 1 times 1, I use this spot, so I go to the right. Stop. Add this guy down and add this guy, because you're done. So this gives me 7, negative 1. This was my x1, my x0, and this is my remainder. So start it backwards. x0, x1. 1x plus 1 plus, here's my remainder, 7x minus 1 over that whole denominator. And if you like, I like to put that in parentheses just so that it doesn't get confusing.
Way back up there, why did you put another number under the 3? Not that one, yeah, that one.
Because I stopped and added that row down. When I did the first multiply, this 1 times 3, I went to the right. Then when I had to do this one, I have to go to the right of this one. I have to go to the right again. I already used this spot, so I have to go here to this right. I used that one. Then when I stop, it's like starting all over again. Here, then to the right of it. I have to keep going to the right of it. You only add down one column at a time until the very end, and then add down whatever else is left. Okay, this one takes a little while to get used to. You also need to be careful if they do this. If this is in your denominator, what term is missing from this? An x1. So I've got x squared plus 0x1 minus 1. My leading coefficient is 1. If I take this out the opposite, it's still a 0. If I take this out the opposite, it's a 1. So be careful when they do that, because they love to do that one too. Miss a term in the denominator as well. You need, whenever you're like dividing, you need space holders. You do the same thing when you divide regular numbers. You have space holders in there. They're automatically there. So we have to put them in a little bit.